Services for Securicon. We're a security provider out of the Washington, D.C. area. We also have a local presence here in the Columbus area. Securicon as a company, it's a 13-year-old company. It's always been involved in the industrial control and process control systems arena. What some electric industry people will know and love as the NERC SIP requirements. Actually started life as Urgent Action 1200 right after the 9/11 incidents. We were part of the team that helped formulate the Urgent Action 1200 and then 1300 and then NERC SIP version 1. So this is an area that's kind of near and dear to our heart, risk and security in the industrial control and process control environments. So what I'm going to talk about, also if you've seen an earlier version of the agenda, the guy originally who was going to give this presentation is one of my senior engineers. He had a knee injury and is stuck in Seattle at the moment, unable to travel. So if you like everything you hear, I'll take credit for it. If you don't like anything, it's his fault. Okay. So what I'm going to talk about is kind of an annotated case study. This is something that we put together for an actual client. So I'm going to talk about the opportunity that was presented, the approach that we came up with, and then how the framework it evolved and where it is today. So this is this is a reality show, I guess is the message. Before I get into detail of the presentation, I was at the SANS ICS SCADA Summit in earlier in the year, and there was a panel that was talking about the ideas of risk and cybersecurity in the ICS and process control world. And some of the concepts that they said, if you look on at things like the IT OT conflict, so you've got the IT people side of the world, the traditional network security people, and look at the operations technology people. They work under a different agenda. The primary agenda of the OT people is availability. Keep the systems up, work through problems, and if a system goes down, that's a lost revenue, that's added expense, that's a major problem. So if you look on the IT side of the world, system gets infected, something goes down, you isolate the system, you remove it, and you take an outage for a while, and you're okay. Those philosophies are in conflict when you start trying to do IT solutions or look at things that IT risk in an OT environment. Two concepts that come out that came out of the ICS Security Summit were, if you look at the dichotomy between IT and OT, reality is really somewhere in the middle. They're both right, they're both wrong. So the attempt in here was to try to balance things. The other thing that description I liked is when you start talking about risk and trying to identify risk and quantify risk, it becomes a team sport. It's more like a rugby scrum than an actual qualitative discussion, because people's perceptions of what risk is flavored by their own view of what reality is. So the opportunity that we had was a major global consumer products company. Odds are excellent that you have their products not only in your homes, but also probably in your luggage, even as we speak. They've asked us not to identify them, but they have given us the okay to discuss the program that was developed. So the intent was to really kickstart an ICS security program. This is a company that is in they have 20 factories in 18 countries. Some of the countries are countries you wouldn't necessarily want to go to regularly. So there are a lot of third world locations. And the idea was to begin assessing the security program, getting an ICS security lead hired, because they didn't have one, never had one, excuse me, and develop a framework for implementing ICS security across the corporation with an idea of standardizing concepts of risk and impact. So what's a framework? So the key questions to be answered, just to define what the framework is what's its purpose, what are its functions, and the scope. So the purpose of the framework from a philosophical standpoint is the ICS systems are the foundation of the production systems in factories, and they have to be safe, secure, and reliable. If they're not, they could impact things negatively, and things could be customer satisfaction, your cupcakes smell funny, or corporate revenue. Because the cupcakes smell funny, they don't really make cupcakes, by the way. Because they smell funny, people don't buy them. Because people don't buy them, there's a financial impact, a revenue impact to the company. So the framework is really designed to establish the elements of security for the plants and factory operations, and that includes architecture, design, procurement, operations. So really the whole chain of logistics, if you will, of keeping the production lines running, and how do you repair rather, and provision or decommission them in time. Overall intent is to complement and integrate with an overall security, cybersecurity and physical security controls, and with the regional and national laws, affecting the company. Excuse me. So if you look at a conceptual framework, a good piece of information to start from is from the Congressional Research Service, the CRS report for Congress down there. That particular publication, the complexity of the challenge, is really a governmental view of what the issues are, IT versus OT, and how to put things together. So the questions that document poses is, for the framework, does it help the analyst or policy maker understand and provide structure? Does it help focus on dimensions of policy design? Does it generate additional hypotheses for future action? And does it offer guidance for prioritizing actions? So if it meets all those criteria, then, it's an effective framework. We used the ISA, Security of Industrial Automation Controls glossary as kind of a gospel, if you will, as we went through here. So it defines ICS. We were talking about definitions. Its definition of an ICS is personnel, hardware, and software. Yes, it includes people that can affect or influence the safe, secure, and reliable operation of industrial process, and is involved in the operation of industrial processes that can affect or influence safe and secure, reliable operation. Systems, include, and this is the alphabet soup of different systems that you'd find in not only a manufacturing environment, but a lot of control organizations. Distributed control systems. You have factories in different locations, and you have to coordinate between them. Program logic controllers, RTUs, intelligent electronic devices. IED here is a good thing. IED on the battlefield is not a good thing. Same acronym, different meaning. SCADA, the system control and data acquisition, networked electronic sensing and control monitoring. And that includes something that is usually overlooked when you start talking about, this type of system, and that's safety instrumented systems. Even though you're making cupcakes, if the batter is in a pressurized container, you have a potential explosive situation. So how do you monitor that? How do you, program safety controls to keep the tank from rupturing and splattering everybody with hot batter? I love cupcake analogies, if you haven't figured that out. And then associated information systems. Once you get all the technology put together, the associated human network or machine interfaces that control all that. So systems that you have to take into account when you do these include, both the human and the technical pieces to bring everything together. So we talked about IT and OT. So traditionally the IT view of the world has the same chart, but reverse. It's usually confidentiality, integrity, and availability. OT is availability first. And that changes how you think of the world. So in what we did is we put together a reference model, and this is based off their Purdue model, which is one of the ISA 99 reference architectures. If you look at how this is structured, this is a little different than what, if you were mapping things out, how you might do it. If we're talking about, industrial control systems, it's actually working from the bottom up the way this chart is put together. So your DMZ between your corporate and process control arenas is separate. It's the yellow line in the middle there. But if you look at the structure, you get the level 0 is the PLCs and the RTUs and the devices that are actually doing low-level control and, being the logical equivalent of flipping switches and controlling the organization. That's the level 0. Above that, you have the basic control devices, which are controlling the process that's running. The safety instrumented systems are the ones that are making sure that nothing is impacting the work area or the environmental areas. That could include things as such as gas leaks outside or explosion containment or other fun stuff. And again, just because you're making cupcakes doesn't mean things can't explode. And then level 2, next level up is the area and supervisory control, taking it from the process level to the facility level. And you could have multiple facilities within a plant. And level 3 is you're really the site level, so controlling the various operations. Increasingly, in the good old days, not too, probably 15, 20 years ago, a lot of companies kind of ended at that level. A facility was a facility was a facility, and the guys back in the headquarters, you just send them a paper report every once in a while as to what's going on. Increasingly, that is automated. Requests from headquarters to automate the reporting of production, no longer weekly, now hourly, now instantaneous reporting. So the amount of traffic that's going up to the level 4 layer has really exploded over the last couple of years, both with new types of equipment that are coming into these areas, and with new requirements coming out, from businesses just for managing themselves. What becomes important to recognize when you start doing this is the age of technology that's being deployed in this architecture is generally going from fairly new to possibly fairly old. In a manufacturing facility, it's not uncommon to find 30, 40, 50-year-old RTUs and PLCs. The basic technology hasn't really changed. And some of these equipment have very long life cycles. So when you start talking about cybersecurity, a PLC that was manufactured in 1978 probably has a different profile, security profile, than one that was manufactured in 2014. And that you have to be able to encapsulate that and recognize that in the standards that you use to proceed. But what standards do you follow? So you have an alphabet soup of different approaches that different people have used. Kind of the two standards, if you will, are NIST and the NIST Cybersecurity Framework. That last one is also known as Executive Order 13636, and it's something that's being recommended is the word the government uses in a number of critical infrastructure organizations. Some organizations are treating that as, it's recommended today, tomorrow it probably is going to be mandatory. One, just as an example, one industry that's kind of taken that to heart is the water industry. If you look at the American Water Works Association security guidelines, it reads almost word for word identical to the NIST cybersecurity framework. And that's something that's evolved recently. There are other standards. RIPE is one that's just coming out. It's a little different. There's a couple of European standards that are similar. They all kind of push back. Since we're looking at an international organization in this case, we went back to NIST because NIST 853 was kind of the common factor in all of them. So we took a NIST 853 focus and started looking at systems and looking at a couple of areas of focus first. So the risk analysis, system and services acquisition, configuration management, and awareness and training were really kind of what we figured the first area of interest would be, because that took care of, understanding what people knew. So people are part of the process. So the understanding what people understood, trying to get a standardization on the risk analysis process. Is factory A, you lose factory A, do you lose as much or more or less if you also lose factory B. Configuration management. One of the things that is sorely lacking in a number of manufacturing industries is knowing what's out in the factory. In some cases, if a production line has been running for 30 years, nobody has bothered to update any diagrams or inventory lists or anything. So you know what was built in 1978. You don't know what happened between 1978 and today. So, getting arms around that and getting people to understand, risk of that particular configuration became kind of a priority. What was done for this client is, if you want to know what's out in a factory and there is no configuration list, you got to go to the factory and create that. So that became an around the world trip to figure out what was in place, how was it being controlled, what kind of state was it in. Did the people understand what they were working with, and that was let's just say the team got to go to some very interesting places. So the conclusion was the foundations to use. So we're using this NIST umbrella, but we had a couple of influences in there. The ISA 99, automation control security standards were a heavy factor in there. The NIST 882, which is SCADA specific, there is overlap between 853 and 82, but 82 does bring in the SCADA and the industrial control aspects. Then the ISO 2005 and ICS CERT recommended practices. I am required to point out by my management that we run ICS CERT. So we are, SecureCon is a sub to Idaho National Labs, and we actually staff and do research for the CERT. That's the federal half of the company. I work on the commercial half. So the control matrix that we put together, if you've done anything in a NIST world, this should look very familiar to you. Basically, we took the standard kind of NIST risk assessment framework that you would have, and basically would rank, the different systems within the plants, certain key systems, against the NIST criteria, would assess both the impact and possibility of compromise or loss of those systems, and the impacts that would create. When you start looking at those, the ideas of low versus moderate versus high impact, this is a table straight out of 882. If you look at the first line, injury, low impact, cuts and bruises requiring first aid. Moderate is required hospitalization. High impact, in that example is loss of life or limb. That's intended to provide a guideline for ranking things. What we actually looked at, so taking that as kind of a baseline, if you will, what we ended up doing is gathering different stakeholders from the different parts of the company and started trying to force them into and I do mean to use the word force them into a standard understanding of impact and financial, financial ramifications and likelihood of compromise. This particular company, one of their products is pest control materials. So some of that is distributed in the U.S., some is only in, third world markets. But, compromise of a factory, everybody in that industry thinks back to the Bhopal, incident, 40,000 people, killed. It's nothing like that for this particular company, but that's always in the top of everyone's mind. But the other side of it is, so I have Factory A who makes this, these deadly chemicals, and the processes they use themselves, could inflict harm, and so you talk to the plant managers and the product managers on that side of the company, and they have a very specific view of the world. One of the other products the same company makes is, I mentioned at the beginning that there's something that was probably in every one of your homes and possibly in your luggage if you traveled here. One of the products they make, there are things like Kleenex. Kleenex is really a brand name, but, people use it categorically for a generic product. Well, one of the products they make is in that class. So everybody knows the product by their brand name, but it's used generically. So you talk to the guy in that factory, and, so you talk to these two guys together, and you say, loss of this plant, is, if I lose plant A that has these deadly chemicals in it, there could be loss of life, there's horrible, public relations, this can damage the environment for a long time. And you talk to the other benign product guy, and he says, we have a compromise in that one, and that's 60% of the corporate revenues. And it's, when you do risk assessment, unfortunately, it comes down to dollars and cents, but that becomes, kind of the first point that you have to get people to agree on, that what's reality. Kind of take the emotion out of it and start looking at things, more from a balanced viewpoint. So if you look at this chart, this is possible definitions for impact levels, from that same 862 document. So, if you look at the first line, products produced, non-hazardous material or product, versus, as you go up, some hazardous product to critical infrastructure. But the last item on there is ingested products, under high impact. So you could have something that's, non-hazardous, but ingested, and, to understand what that impact is, you have to have some kind of balance in the discussion. So that brings you into, how do you rank these things? So we started with this kind of, basic notional maturity model, for lack of a better term, where things were being controlled ad hoc. Local management got to say what was being protected, or, was it only a partial implementation? And in doing our around the world tour, almost everything was in one of the bottom two categories. So things were either being done randomly. I use the term maturity model. One of my favorite terms from the Carnegie Mellon, system maturity model was the ad hoc solution. Says this is level 2 on the maturity model. Ad hoc is success is dependent on the heroic actions of a few, and that was what they were seeing. So some sites were had good programs, but it was because Bob worked there, and some sites had questionable programs because somebody else, Bob's equivalent in another factory, didn't view things the same way. So the program became to see what they could do to drive everybody up into a more repeatable managed layer first, get everybody working with the same processes. And until you got people from orange to yellow, then you could move to green from there. So, so some common constraints, we use the idea of essential functions, and that's a function or capability that's required to maintain health, safety of the environment and the availability of the equipment under control. The selected constraints, that have to be followed. And this is from one of the ISA publications. So, you don't want the security measures to adversely affect, the functions of a high availability ICS unless supported by a risk assessment. Shouldn't cause a loss of protection, loss of control. Access control shouldn't prevent the operation of essential functions. And, you get down to the last one, and that's a denial of service event on the ICS, or SIS. SIS is a security instrumented system, shouldn't prevent the SIS, the security functions, or safety functions rather, and its associated functions from acting. So, ICS, the only thing ICS was secondary to was the safety systems. So exceptions, this is a part of the final presentation. That section focused on the need to allow for, exceptions to the framework, and that was based on either technology or, business function, or, we had a set of exceptions defined, and they needed to be reviewed for business risk and approved by plant management before, they were accepted. And with any exception, there has to be a review cycle. So, it seemed like a good idea to give them the exception this year, but do they keep that in perpetuity? Probably not a good idea to let them hold on to it. And then it's great to have standards. It's great to get people to comply, but you also have to be able to, to enforce compliance. So systems out of compliance, if, are subject to disconnection from the network, and employees face, disciplinary action. If you have vendors and third parties involved, termination of the contract and their loss of business with the company, then becomes, an article that you can push to enforce compliance. So the summary of the framework, putting everything together, the framework that we had, basically follows, that model. So everything down to Appendix A, these are, consider them sections of a report. So we have the purpose for it, the definition of a conceptual framework, the scope, and the philosophical view of ICS, how you're applying them, how you're doing risk and impact analysis, and getting down to the appendix. The appendix, the controls matrix, is actually the result of the global assessment. So the plant by plant, comparison to what the risk impact of the different places are. The other part of the intent in doing this was, once you have this Appendix A piece, the plant level, controls matrix defined, that gives you the point from which you can measure improvements. So you know what it looked like when you assessed it this year. Let's say they have enough plants that they don't do this annually. So, if you're doing this in a recurring cycle, every couple of years, revisit the plants, have planned risk reduction programs in place, to improve risk. That gives you, the mechanism to do, comparison. This was a moderate, last year. It's a low this year because of these things we've put in. And that also lets you look at, return on investment for the process of improvement. We invested $2 million and we didn't change our risk profile. That's probably not a good thing. So if you have improved it, you can quantify what worked. You can actually do it at the plant level. What worked, how much did we invest in it? And then be able to take that and say, well, that plant looks like that one. Was an improvement there. We should do it in this other plant and basically duplicate the results. So the future, this is, this is actually current. This is being used globally. They visit the original Around the World tour, did about 1/3 of their plants. They are doing another section of their plant inventory this year, and they're continuing to refine the process. So, questions? Comments? Yes, sir.
So what was the worst common problem? The framework was always traveling the top all these people and all this stuff. Although there were different plans, there must be something common.
The two biggest problems were lack of knowledge of inventory. So you would show up at a plant and say, show me the production line, and they would take you to the production line. And if you ask any question beyond that, I don't know, it's, well, what does this box do? I don't know, but if the light's green, it's good. And so being able to start dissecting some of that. Not in all sites, but in a lot of the sites, especially the third world sites. It was a combination of one of our guys and two of their guys. So you want to talk about a mileage, expense report. That was done kind of 2 loops of the globe. Yeah, so they've embraced a configuration management philosophy. So they have a list of what's where, and they now have a requirement to, to tell people when they change something. So this RTU went out, replace it with something else. I said there were two problems. So inventory is one, and people was the other. Because even in domestic plants, people didn't know what the components of the process were. There was a whole lot of, green light good, red light bad, philosophy. And, this was true with people who had worked there, 20 years. Nobody had ever changed anything. So. Yes, yeah. So just knowing it works, the cupcakes are coming off the line, but how they got there is kind of where the miracle happens. Yes, sir. Could you say that a little louder? What can I say? Okay, the following is my opinion, not necessarily the opinion of Securicon. Okay. There is DOE has not really a one-size-fits-all, but kind of a simplistic view of the world. And if you look at the electric industry, you really have a number of different segments. And you can't really apply the same policies and processes to all. Now, if you look at an investor-owned utility, they are responsible to their stockholders. They have let's take a municipal utility as another example. They're more related to a community. They may be more of a public utility. The investor-owned utility probably has more money to spend on things. The municipal doesn't. Yet they both have to look at generally the same federal standards and the same public utility commissions requirements that they have to play with. So how those two organizations would respond could be significantly different. So I don't think in the DOE model it adequately breaks those down. Then you have all sorts of other variations on the theme, distribution versus transmission, the energy trading, things like that. It gets awfully exciting awfully quickly. Yes, sir. Yes. It can be. 80% of the time it is. And it kind of becomes, depending on the utility, it could be a blue collar, white collar thing. It could be a young guys, old guys thing. I know one utility where they call the IT guys the college kids. So it's the college kids and us. So it's embedded in the, it's class distinction in some utilities. It's age in some. A lot of OT guys look like me. So, other questions? If not, thank you very much.